These are right triangle trigonometric ratios. Sine theta equals opposite over hypotenuse. Cosine theta equals adjacent over hypotenuse. Tan theta equals opposite over adjacent. We also have cosecant theta is equal to the hypotenuse over the opposite. Secant theta is equal to hypotenuse over adjacent. And cotan theta is equal to adjacent over the opposite. Notice that cosecant is the reciprocal of sine theta, secant is the reciprocal of cosine theta, and cotangent theta is the reciprocal of tan theta. Now, in order to decide what these lengths are, as far as opposite, hypotenuse, and adjacent, we can look at a right triangle. The hypotenuse is always opposite of the 90-degree angle. And wherever theta is, that dictates which side is opposite and which side is adjacent. In this case, since we have theta down here, opposite is whatever's opposite of theta, and adjacent, it's what's right next to theta. If theta happened to be up here, that would change. So let's apply it. Let O be a point at the origin, and P be a point on the terminal side. Find the missing values, correct to 3 decimals. So what we have is P, negative 3y, so point P is at negative 3y, and theta equals 120 degrees. Well, first we want to draw a reference triangle. I know that 120 degrees is between 90 and 180, so I'm going to go ahead and draw the terminal side. The terminal side being over here in our second quadrant. And then I know from here to here is 120 degrees. Now to draw my reference triangle, remember it's a line that goes from the terminal side down to the x-axis. And that's going to give me my reference triangle. And I'm going to find this angle that's inside my triangle. Well, this is 180 degrees. This is 120 degrees. I'm going to subtract the two. So 180 minus 120, and that gives me 60 degrees. So this angle is 60. Negative 3, which is my x-coordinate, is going to go here. In order to use my trigonometric ratios, I'm going to take the absolute value of negative 3 so that I get x equals 3. Now, 3 is adjacent to 60. The missing coordinate y is opposite of 60 degrees. So I can see here that tan theta equals opposite over adjacent. So I'm going to use tan 60 degrees equals opposite is y, adjacent using 3. Now I'm going to solve for y. I'm going to multiply both sides by 3. So I get 3 times tan of 60 degrees equals y. And now I'm going to use my calculator. Be sure that your calculator is in degree modes. If it's in radians and you're using an angle that's in degrees, you're not going to get a correct answer. This goes the same if you switch it. Okay, if you're given an angle in radians and your calculator's in degree. So in this case, my calculator was in degree mode. So 3 tan of 60 degrees gives me 5.196 equals y. Now I have to decide what sign it should be, whether it's positive or negative. In this case, since y is in the second quadrant, it's positive. So my coordinates for P is negative 3, which was given, and 5.196. Now I can also find both missing coordinates given the length of the terminal side. In this one, the terminal side, OP, is 7, and theta equals 230 degrees. So again, I'm going to draw my reference triangle, and since I'm told that theta is 230 degrees, that angle is between 180 and 270 degrees. So that means it's in the third quadrant. So I'm going to draw my reference triangle. There's my terminal side. And I know that from the x-axis to the terminal side, it's 230 degrees. And for my reference triangle, I'm interested in this angle. Well, I know that this is 230. Here, it's 180. So that means I'm going to take 230 degrees and subtract 180 degrees, and that's going to give me 50 degrees. So that's the angle for my reference triangle, 50 degrees. The terminal side, OP, is 7, which is going to be my hypotenuse, and I'm looking for x and y. Well, I'm going to find x first. X is adjacent to 50 degrees. So cosine theta is adjacent of hypotenuse. So I'm going to use cosine of 50 degrees equals adjacent, which in this case is x, over the hypotenuse, which is 7. I'm going to then multiply both sides by 7 and get 7 cosine of 50 degrees equals x. Plug that into my calculator. I get 4.500 equals x. Well, since x is in the third quadrant, that means it's got to be negative. So my x-coordinate is actually negative 4.500. Now to find my y-coordinate. The y-coordinate is opposite of 50 degrees. So that means I'm going to use sine theta. So sine of 50 degrees equals y over 7. Going to multiply both sides by 7 to get y by itself. And then I will use my calculator and I get 5.362 equals y. Again, in this case, y is in the third quadrant and therefore y is negative. So the actual answer is negative 5.362. So my coordinates are negative 4.5 and negative 5.362. And this is how we use right triangle trigonometric ratios to find the missing values.